When I was benchmarking for this video, I realized a very important thing. In my previous video, I was talking about a BIOS setting that should be changed after installing a discrete GPU into my build. That setting is called dGPU only mode. And you can see the setting BIOS path on the screen. This setting should be set to enabled, otherwise you could lose some gaming performance. In my case, it was around 1.5% in Marvel's Guardians of the Galaxy. Let's investigate how much performance changes when adjusting the power limit slider towards negative and positive values. The benefits of lowering the power limit would be lower temperatures and noise with a slight reduction of performance. On the other hand, increasing it could result in higher FPS but with higher temperatures and noise levels. Is it possible to regain lost performance when reducing power limit with overclocking? You will see. Firstly, I've started benchmarking Cyberpunk 2077 from -30% up to 10% in Full HD resolution with a step of 5%. All settings can be seen right now on the screen. Vertical axis represents relative performance and horizontal power limit. Line has roughly the same curvature in negative and positive power limits, slightly starting to flatten out sooner at positive offset. It has a 2.3% performance gain at +10 power limit compared to a 2.9% performance drop at -10% power limit. So it is not linear, which in this case means that increasing power would flatten out rather sooner than later, and decreasing power has a higher impact on lowering performance. I would say that AMD's engineers chose a decent point for power consumption at 300 watts. Going higher has increasingly diminishing returns, efficiency is getting worse. After these results, I was curious whether the behavior is the same for every game. The answer arrived sooner than expected, right after testing the next game, Marvel's Guardians of the Galaxy. The curvature of the line at increased power limits seems to flatten out even sooner than in case of Cyberpunk. Overall, the curve is flatter and the impact of power limits on performance is much smaller in both directions. At +10% power limit, performance gain is only 0.6%, which is 4 times smaller than in case of Cyberpunk. On the other hand, reducing power by 30% reduces performance by only 6%, which is almost half when compared to Cyberpunk's 11.5%. I know, those games ran at different resolutions, but that is because I wanted to measure higher FPS values, bigger numbers, in order to reduce percentage errors. We will get to this. What does this all mean? The ultimate idea was to reduce the power limit and at the same time overclock the GPU so that we get the same performance as with the default power limit but with better power consumption, temperatures and noise. Since each game behaves differently, we cannot set this globally, which means we would need to create profiles per game. Now, you might also question whether the behavior changes with resolution, and that was my question as well. So I tested both of these games with different resolutions. And indeed, changing resolution slightly alters the performance power curve in both games, and we had a similar experience with overclocking results for this card. Check out the video about overclocking the RX 9070 XT if you have not seen it yet. It seems higher resolution correlates with higher performance impact. Or it is harder to measure relative performance since average FPS values are lower, so percentage calculations might be less precise. Either way, the difference in resolutions within the same game is insignificant compared to the difference across different games. In our tests, Cyberpunk is at least twice as sensitive to power limit changes as Guardians of the Galaxy. Here is the comparison of these games at at 2.5K resolution. For Cyberpunk at this resolution, I did not capture average FPS values for power limit at steps of 5%, but rather only at steps of 10%. Has no impact on the overall message. For those who are interested in raw data, here is the spreadsheet. Ultimately, the decision what to do with your card is in your hand. I just wanted to point out that it is not as simple as finding one power limit value and setting it globally. In case of two tested games here, and with my globally stable GPU overclock, which is minus 80 mV core voltage offset and 2736 MHz VRAM, to match stock performance, I could lower power limit for Guardians of the Galaxy to minus 25% and for Cyberpunk to minus 17%, which would save me 75 watts and 50 watts respectively. And finally, you can see on the screen how much effect this would have on GPU hotspot temperature, VRAM temperature and fan speed. Keep in mind that the FPS values are affected by recording and performance monitoring overlay, but since both tests are using the same conditions, they are comparable.